everyone. Welcome to Learning at 11th Hour. This video is going to be about implementation of logical functions, but this time we are not going to go for the normal method where we use the K-map to obtain the simplified expression. We get the expression in the standard SOP form and we use and OR gates and if required, NOT gate to implement it. We are only going to use multiplexer to implement any logical function. Let's see how this can be done. So this case is where we are not going to have any extra added gates like the and the or. We are only going to use the not gate wherever required. Suppose I have a function that is f of a, b, c and d, and the minterms are 0, 1, 3, 4, 8, 9 and 15. I need to implement this particular logical function and I have to use only the multiplexer. So there are four inputs over here, A, B, C and D. So 2 to the power 4. If I use all the four inputs as select lines, I'll have 16 combination of inputs. So if I can ensure that this is my 16 cross 1 MUX, if I have a 16 cross 1 MUX available with me, then I can ensure that I0, I1, I3, I4, I8, I9 and I15. All of these are connected to 5 volts or high. Why am I doing that? Because my intention is to ensure that when A, B, C and D inputs are connected as select lines, and when the combination of ABCD is such that it chooses I naught as the input to come out in the output, then the value of this function should be high. So when ABCD is 0, 0, 0, 0, I naught will be conveyed to this output and F should be high. Similarly, for I1, for I3, for I4, for I8, I9 and I15. So for any combination of ABCD out of these from 0, 1, 3, 4, 8, 9, 15, whenever that is available, that combination is available in these control signals, that particular input will be chosen to go to the output. Then the value of that input should be high because after all, the truth table for this particular function is such that for these minterms, the function's output is going to be high. So these are connected to plus 5 volts and the rest of the minterms, which are not mentioned over here, should be grounded. So now this particular image shows all of the minterms that are, or all of the possible inputs that will be available in the MUX, and we'll see how we can connect it. So for this particular logical function, to implement it using a 16 cross 1 MUX, we need to choose all the four external inputs A, B, C, D as select lines, and only the minterms mentioned in the problem should be all connected together to plus 5 volts or high, and the remaining are to be connected together in such a manner that they are going to be grounded. So this is the output of this multiplexer and this is how it should be connected. In that case, for example, if A, B, C, D is 0, 1, 0, 0, this corresponds to 4. So therefore, I4 will be conveyed to the output and I4 is nothing but 1 because it's connected to 5 volts. So for that combination of A, B, C, D, F is going to be 1. Similarly, if 0, 1, 1, 1 is the combination of A, B, C, D, then F should actually be 0 because this minterm is not available in our problem. 7 is not there. So therefore, according to our truth table, the output function F should be equal to 0. So if we notice here also, it is going to choose I7, and I7 is nothing but grounded. So therefore a 0 will be conveyed to the output. So if we are going to use all the four external inputs as select lines, then 2 to the power number of select lines is going to be the number of inputs of that multiplexer. So we need to have that large number of inputs available for a multiplexer to be able to implement it directly for this particular problem. Suppose we don't have a 16 cross 1 mux, we have only an 8 cross 1 mux. So that means there are only 8 inputs that are going to be possible. So that means I can have only I naught to I7. And to choose this, 2 to the power 3 is going to be 8. So 8 inputs, which means I have 3 select lines. So I will require 3 select lines, and out of A, B, C, D, I can choose any 3 of them to be the select lines. So say in this case, I choose B, C, D to be my select lines. Then what would happen to A? A will be involved in these inputs I0 to I7. So apart from these I0 to I7 being connected to plus 5 volts and ground, they may be connected to the input A also, or the inverted version of input, that is A dash, would be connected to any one of these inputs in such a manner that this particular function which we need to implement over here is available at the output of this 8 cross 1 mux. So in order to find out what is the combination of ones and zeros of these inputs and whether at all A is involved, we need to go for something called as the implementation table. In the implementation table, we are going to enlist all of the select lines, and for different combinations, say 000, 001, 010, 011, 100, 101, 110, and 111. So for all of these combinations, it is going to choose some particular input. So when it is 000, it is going to choose I0. For 001, it will choose I1, I2, I3, I4, I5, I6, and I7. So these are the select lines. Now there is an external input A which is also available. Now it could either be connected to these inputs in the inverted form A dash or directly as A. When it's in the inverted form, it would correspond to 0, and when it's directly connected, it is going to correspond to 1. We are now going to number these boxes just as how we number the midterms in a K map, only that here we are not following any gray code. But the most important thing is we need to ensure the order of these bits. That is, A over here is nothing but MSB, or most significant bit, and D corresponds to the least significant bit. So we are always going to read the number from A to D. So when I say 0000 or say 0100, for example, I say the number 0100, it literally means that A is 0, B is 1, C is 0, and D is 0. So this corresponds to the number 4. So this is how we have to read the number and fill these boxes. So here we have, this box is 0000. So 0, this is 1, 2, 3, 4, 5, 6, 7. This is 1000 means 8, 9, 10, 11, 12, 13, 14, and 1111 is 15. So you can check out the combinations if they are correct from each of these boxes and verify it for yourself. So this is the first step, to write out the implementation table and number it correctly. The second step is to circle these particular minterms 0, 1, 3, 4, 8, 9, and 15. So let's circle it 0, 1, 3, 4, 8, 9, and 15. So we have to circle the minterms in this manner. These minterms are involved in our given expression. So this circling has an interpretation. So that is our next step. So let's look at each of these columns. If both the numbers are circled, it means that that particular input is 1. Here also, both the numbers are circled. So this particular input I1 is also 1. That means these are connected to plus 5 volts. Here we see none of them are circled. So that means this is grounded. It's a 0. Similarly, we see I5, I6 are also not connected. They are also going to be grounded and connected to 0. Here, only one of the numbers are circled. So here we see I3, the row corresponding to A dash is circled. Therefore, I3 is going to be connected to A dash. Similarly, I4, the row corresponding to A dash is circled. Therefore, I4 is also going to be A dash. And here we see for I7, the bottom row is circled, which means it is corresponding to A. So I7 is now going to be connected to A. So for this 8 cross 1 mux with BCD as our select lines, we have different combinations of inputs starting from I0 to I7 in such a manner that I0, I1 are both high, I2, I5, I6 are grounded, I7 is connected to the fourth input which was not involved in forming the select lines, that is A, and I3, I4 is connected to A dash. So when we draw this, we can draw it in this manner. So we have the 8 cross 1 mux. We have 1, 2, 3, 4, 5, 6, and 7. Here B, C, and D are the select lines. Output is F for this 8 cross 1 mux. Here I0 and I1 are connected to plus 5 volts, that is, they are high. I2, I5, and I6. So I have I2, I5, and I6. They are connected to ground because they are 0. I7 is A. So I'm going to write A over here, which is the fourth input. Just like how we have BCD, this is another input A. And the input I3 and I4 of this mux are connected to A dash. So I can have a NOT gate over here, and that would be connected to I3 and I4, therefore making it A dash. So when we connect an 8 cross 1 in this manner, where A is involved in the inputs, BCD act as the select lines, we will come up with the function ABCD such that its minterms would be 0, 1, 3, 4, 8, 9, and 15 as required by our problem. So this is how we are going to be able to implement any logical function similar to this using just the multiplexer. Now, if we have a large multiplexer available such that as many inputs are required in the function is available as inputs for the mux, I can directly connect all of the external inputs as a select line and obtain the function where the particular minterms involved in the function is connected to plus 5 volts and the remaining is grounded. That was the first case we saw. And the second case is where I use only 3 out of the 4 A, B, C, D as select lines, and one of them will be involved in implementation of the inputs. Now, say instead of B, C, D being the select lines, if I randomly choose, say, A, B, D as my select lines, so then how would my multiplexer look and how should I connect it? So let's write out the function first. So we have A, B, C, D as summation of 0, 1, 3, 4, 8, 9, and 15. And here we are choosing A, B, and D as my select lines. Therefore, C is going to be involved in the connection of my inputs of the MUX. A, B, C, D themselves are inputs, but they are external inputs. And out of the external inputs that are there, A, B, D is the select lines. So let's look at our implementation table now. So we will have C dash and C over here, and we will have A, B, and D over here. So here, as always, this is going to be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. These are the possible combinations of these three, A, B, and D. So now let me see how I can fill up the numbers as such. So this is what I was talking about. Here we need to be careful while we look at the bits. So we are going to look at it as A followed by B followed by C followed by D. So C dash corresponds to 0, C is 1. So what number should come here? So this is A, B, C, D. That's the order. So 0, 0, 0, 0. This is 0. 0, 0, 0, 1. This is 1. 0, 1, 0, 0 is 4. 0, 1, 0, 1 corresponds to 5. 1, 0, 0, 0 is 8. 1, 0, 0, 1 is 9. 1, 1, 0, 0 is 12. 1, 1, 0, 1 is 13. So on and so forth. You can fill up this row also. So here you have 0, 0, 1, 0 is 2. So this is 3. It's because this is 0, 0, 1, 1. 0, 1, 1, 0 is 6. 0, 1, 1, 1 is 7. So 10, 11, 12, 13, 14, 15. So if you can notice a pattern, you can fill up the rest also and you can check it. So the only thing you need to remember is this is the order in which you need to look at these numbers and fill these numbers in these boxes correctly. After this, we can, as always, circle the minterms given the problem. So 0, 1, 3, 4, 8, 9, and 15. So this corresponds to I0, I1, I2, I3, I4, I5, I6, and I7, where we see that I0 is C dash because it only the top row is circled. I1 is 1 because both the numbers are circled. I2 is again C dash. I3 is 0 because none of them are circled. I4 and I5 are both C dash. I6 is 0. I7 is C. So if we look at this, we can implement our multiplexer, 8 cross 1 multiplexer in this manner, where C is going to be our input, and A, B, and D are our select lines. So here I have 0, 1, 2, 3, 4, 5, 6, and 7. This is an 8 cross 1 multiplexer with F as the output. So let's make these connections. So we have, which are the ones connected to C dash? I0. So let me go up a little. I0, I2, I4, and I5. So I0, I2, I4, and I5. All of these are connected to C dash. So say this is C. We see that I7 is connected to C. So I can bring down this wire connected to input 7. And we see that inputs I3 and I6 are grounded. I1 is connected to plus 5 volts. So I1 is connected to plus 5 volts, meaning it is 1. And I3 and I6, they are grounded. So when we make a connection to this 8 cross 1 in this manner, where A, B, D inputs are connected as select lines, and C is involved in framing the inputs of the multiplexer, we will be able to implement the function f of A, B, C, D such that it will satisfy these minterms. So that's all with today's video. I hope the implementation of a Boolean function or a logical expression using multiplexers is clear to you all. In the upcoming video, I'll show you how you can use even smaller multiplexer and use some added gates to implement any Boolean expression.